Hello everybody and welcome to this tutorial on Assassination. Now, in Assassinations, we have two characters, and the victim plays an animation where they're getting assassinated, and the assassin plays a completely different animation, but these animations work in sync with each other. And so it's very important that everything is linked up properly. The positions of the characters have to be perfect. And this can be difficult in games because the starting location of the character being controlled might not be perfect when the player starts the assassination. And in order to make sure that the characters are perfectly aligned, we can use Unreal Engine 5's new motion warping system. Now, motion warping involves moving the character's root motion while an animation montage is playing. And this allows us to control where that character ends up by a certain point in the animation. And if I disable motion warping for my system here, all I have to do is remove this one node. And if I start this animation without motion warping, if I'm not aligned perfectly with the victim, you'll see that when these animations play, they're offset, and this doesn't look right. And so that's why this can be particularly tricky. And motion warping is a way to allow us to get those animations perfectly synced up in space, and so we're going to learn how to do that in this video. This video is made possible by the following patrons. Shout out to new patrons Brickshot, Josh, Cryptic, and Not Games. Thank you all very much. I appreciate your support. Now, if you have your own animations, you can use those as long as you have two animations that work in sync with one another. Now, I have this strangling animation, which basically has the character sneaking up to another character. And it looks like there's this wire, and they wrap it around the neck and strangle the other person, and it looks really cool. And the other animation is designed to be played in sync with that one. So by the time the character sneaks up on them, they put their hands on their throat, and they get strangled, and they fall to the floor. So these two animations were designed to work in sync as long as the game developer is somehow able to get those positions linked up just right. And my strangling animation, you'll notice, is called Strangling RM for root motion. And that's because this is a root motion animation. If I uncheck Enable Root Motion here in the asset details, you'll see that this is actually an animation that moves the character. In fact, it actually moves the character's root component. So if I check Enable Root Motion here, it's going to be using the root motion in the animation itself to drive the character's position in the world. So we'll see how to use that, and this is very important when using motion warping, as motion warping only works with animations that have root motion enabled. And this is why my character has a root bone. So even though this is a Mixamo animation from the Mixamo website, I had to import this into Blender, or you can use Maya or some other mesh editing software, and I had to add a root bone at the very top of the skeleton hierarchy. Now, if I get some requests, I can show you how to do this, but you do need a character with a root bone in order for these root motion animations to work in Unreal Engine. Now, you can join my Patreon and get this starter project. So I'll provide you with these animations and the skeletal mesh that has a root bone in it, along with this root bone strangling animation. And then you should be able to follow along, but you can really use any animations that use root motion for motion warping. Now, I'm going to create my assassin character using this ninja mesh, and it's going to be a very simple character. I basically want to be able to move around and enable my strangling or assassination ability. So in my ninja folder where I have my skeletal mesh, I'm going to right click and make a new folder called blueprints, and I'll have my character blueprint here. So I'm going to right click and make a new blueprint class based on character, and I'll call this BP_ninja. And my ninja is going to need a skeletal mesh. So I'm going to select its mesh, and for the skeletal mesh, I can choose my SKM ninja, which is basically this Mixamo character, only I have a root bone in its skeleton. And I can rotate it by 90 degrees and move it down to the correct location. And sometimes I like to disable snapping so I can move it down onto the ground. And now I have a character. Now I want some basic movement functionality. And I'm going to add some inputs in my project settings. So I can go to Edit, Project Settings, and scroll down to Input. So I'm going to need some axis mappings for moving around. So I'm going to add a new axis mapping, and I'm going to call this Move Forward/Backward. And I'll select this key icon and hit the W key to link the W key to this axis mapping. And I'd like to use the S key to move backward. So I'm going to link the S key and change the scale to -1. And I'm going to need another axis mapping to move right and left. So I'll call this one Move Right/Left. And I'll link this one to the D key, and I'll add a second key, which will be the A key, and this one will have a scale of -1. And I'd also like to be able to move my mouse to rotate my view, so I'm going to add another axis mapping called Turn, and I'll map this one to the mouse X axis. And finally, I'll have another axis mapping called Lookup, and I'll map this one to the mouse Y axis and change my scale to -1, as I don't like the inverted method of rotating my character's camera. So this should all be some basic review for you. So now that I have these axis mappings, I can head back into my Ninja blueprint to the event graph, and I'm going to set up some basic movement. So I'm going to delete those default events and right-click and search for Move Forward and get my Move Forward/Backward axis mapping and simply use Add Movement Input. And for add movement input, I'm going to hook my axis value straight up into the scale. So I need a direction to move in, and I'm going to use my controller. So I'm going to right click and get control rotation. This will get me the rotation of my controller. I'm going to right click on that output and split the struct pin. That way I can just use my yaw. Now what I can do is right click and get forward vector. And if I select Get Forward Vector, I can get the forward vector corresponding to a rotation. So this is not my actor's forward vector. That would be Get Actor Forward Vector. This would give me the forward vector of my actual character. But this function, Get Forward Vector, returns a vector that is based on a rotation that we pass in. And I'm going to right-click on this in rotation and split the struct pin so I can use a forward vector with 0 for roll and pitch, and the yaw will be the yaw of my control rotation. So hooking in that yaw there, this gives me the forward vector corresponding to my controller's rotation, only instead of its complete rotation, I just want its yaw. So I'm going to use that and hook that into world direction. And if I hook that up, now I have my move forward, backward functionality. Now for moving right and left, we're going to do something similar. I'm going to search for move right and get my move right left axis event, and also use add movement input for this. And I'll hook that up. I'll use my axis value for the scale, and for the world direction, I want the right vector corresponding to my controller's rotation. So I'm going to duplicate that, and I'm going to use get right vector this time. And for get right vector, I'm going to split that input, and I'm going to use the yaw from my controller's rotation. And for this, I'll go ahead and hook up the roll as well, just to make sure that it's compatible if our roll ever changes, which it shouldn't. And I'm going to hook that return value up to add movement input. So just with this, I should be able to move around even though my controller isn't actually moving. So to test it out, I can go into a map. Now this is the default open world map, but the starter project that I provide you with has this Assassination map. So I'm going to move into that map, which is basically a default map with the ground here. And I'd like to test this out So I'm going to open up my Place Actors panel and drag in a player start. And if I'm going to use a player start, I need my game mode to select my default pawn. So in my world settings, I can override the game mode here, which means I need a game mode. So I'm going to go to my content folder, make a new folder called game mode. And in my game mode folder, I'm going to create a new blueprint class based on game mode base, and I'm going to call this BP underscore assassin game mode. And in assassin game mode, I can simply choose my character blueprint for the default pawn. So here's the default pawn. I'm going to choose BP Ninja, compile save, close that out, and back here in this assassination map, I'm going to choose my game mode override by selecting BP Assassin game mode. And now if I press play, I have my assassin. And I can move around left, right, back, and forward. Now, of course, I don't have a camera or a spring arm, so that's going to be something I need. So I'm going to select my capsule component, which is my root, click add, and choose spring arm. Get me a spring arm component, and I'm going to select that spring arm and add a camera. So I'm going to search for camera and get that camera there. And now I have a camera component attached to my spring arm. And if I go ahead and press play, now I see that my character moves and I have a camera and I'm not stuck to the root component's location with my view. But I do want to be able to move my camera around, so I want my spring arm to follow my controller's rotation. And that means I need to change my controller's rotation with mouse input. And that's why I made those turn and look up axis mappings. So I'm going to search for my turn axis event. And with turn, I'm going to call add controller yaw input and simply hook that axis value straight in. And I'll do the same thing for look up. So with lookup, we'll be doing the same thing, except I want to add pitch input. So I'm going to use add controller pitch input and hook up that axis value there. Now, if I press play and move my mouse, I see that my character is following my controller, but I want my spring arm to follow the controller instead. So what I'm going to do is select BP Ninja Self and search for use controller rotation and uncheck use controller rotation yaw. That way, if I move my controller, my character doesn't rotate along with it. But I want my spring arm to do that. So in my details panel with the spring arm selected, I can scroll down to camera settings and check use pawn control rotation. If I check that and press play, now I have control rotation with my mouse input and the spring arm follows that. So now I can move around and change my view and it feels much more natural. Now I do see that my character is raised above the ground just a bit, so I'm going to select my mesh and lower it down a bit further until those feet look planted. So that looks great. Okay, so that takes care of basic movement, but my character is in the T pose, so I need an animation blueprint. So I'm going to go back into my Ninja folder, and here in my blueprints folder, I have BP Ninja. I can make an animation blueprint here. And I'll select my Ninja skeleton and call this ABP underscore Ninja. And I can open this up and create a very basic state machine. So I'm going to add a new state machine and call this locomotion and simply hook it up to my output pose. And locomotion will be simple. I can just have idle and sneaking. So I have this idle animation. I'm going to drag that in, and I have a sneak walk. I'm going to drag that in and simply hook these up to each other. And now I have two states. I'll start off in the idle, and I need to transition into sneak walk, which means I'm going to need to know my character's velocity. Now, in my event graph, I can come down here into my functions and click the drop down for override, and I have this blueprint initialize animation. I can use this, and I can use try get pawn owner to get the owner of this animation blueprint, and I'd like to cast it to BP Ninja. And then I can simply store this in a variable. So I can right click as BP Ninja and promote to variable. And instead of as BP Ninja, I'm just going to call this character. And once I have the character, I can access its properties such as the velocity. And that's really all I care about is the velocity. In fact, I really only care about the x and y components of the velocity and not the z. So what I can do is add another variable called ground speed, and this can be a float variable. Now I can set this here in Blueprint Update Animation. If I want to, I can simply update that character speed. Now there are ways to use multi-threading with animations, and I covered that in one of my bow and arrow videos. I'll put a link in the description if you're interested in using multi-threaded Blueprint Update functions to optimize your animation blueprint, but this is a simple project. All I really need to do is get my character's ground speed. Now that means I need the movement component, so I'm going to drag off of my character and type get character movement to get the movement component. It's going to be down at the bottom, and I'm going to promote this to a variable and call this movement component, and that way I'll have my movement component and I can access the velocity from that. So I'm going to get my movement component here, and I'm going to right click and convert this to a validated get so I can make sure that it's valid before I access it. And I'll type in velocity from this, and down at the bottom we have get velocity, and from this I can type length and use get vector length xy, and this will simply give me the magnitude of the vector but not taking the z into account, and I'm going to use that to set my ground speed. So is valid will go into set ground speed, and now we'll have our ground speed every frame. And back in my locomotion state machine, I can transition from idle to sneak walk if my ground speed is not 0. So I'm going to get my ground speed in here and check to see if it's greater than 0. If it is, we'll transition, and then back from sneak walk to idle, we'll transition to that if ground speed is equal to 0. So very simple animation blueprint here. And if I go ahead and go back to BP Ninja, select my mesh, I can select my animation blueprint, ABP Ninja, compile that, and we see that we're in the idle state, and I can press play, and I can sneak around, and I see that I'm not orienting to movement, but that's okay. We can fix that. Now, I actually do have a different idle animation for the Ninja, and that's actually called Ninja Idle, so I can use that instead of this regular idle. That's the one I was planning on using, so I can compile that, and if I press play, now I have this more ninja sneaky idle. Now to orient rotation to movement, what I have to do is select my BP Ninja self and make sure use controller rotation yaw is unchecked, so I don't want that checked. I can select my character movement component and search for orient rotation to movement, and I can check that checkbox, and now if I press play, then I'll orient in the direction of movement, and now it looks more natural. Okay, so this is a basic animation blueprint. We have basic movement. Now for the topic of the video, which is to actually implement assassinations. And to implement assassinations, I need to use an animation montage. And I'm going to use this strangling animation, which has root motion, in my montage. So I'm going to go into my animations folder and find strangling RM for root motion. And I'm going to right click on that and go to create and create an anim montage. And I'm going to call this AM for anim montage assassinate. And assassinate is just going to have this strangling RM animation, and I'd like to be able to play this from my character blueprint. And in order to play montages, I have to use the slot that this montage is using. So it's set to the default slot, which means my ABP Ninja needs to use that slot. So back out in my anim graph, I'm going to simply drag off type slot and use that default slot. And now when I play an animation montage that's using the default slot, it'll take over my character's animation. And in order to play this animation in response to, say, a mouse click, I need to go to project settings and add a new mapping. And I'm going to add an action mapping for this, so I can simply assassinate with the left mouse button click. So I'm going to call this one assassinate and link this to the left mouse button. Now if I click the left mouse button, assassinate will be fired off, and I can implement that in my Ninja blueprint. So I'm going to come back to the top here and right click, type assassinate, get that action mapping event, and in response to assassinate, I'm simply going to play an animation montage. And to play a montage, I have to get my mesh, And from the mesh, I can type montage, get a play montage node, and hook that up. And for montage to play, I can select AM Assassinate. And if I press play and left click, I'm playing the montage. And notice that my character's root component is moving because this animation has root motion enabled. So if I type tilde and show collision with that console command, I can see my capsule component is moving along with this animation. So this is a key component to motion warping. We'll have to have an animation that uses root motion, as the animation itself is driving the root motion of our character, and motion warping will allow us to control that root motion and set a target point to move to. So this is the first step. We have our montage playing, but we also need a victim. So we're going to create a new character called Victim that we can assassinate. So we're going to go back out into our content folder in characters, and I'm going to make a new folder called Victim for the victim character. And in Victim, I'm simply going to make a new character blueprint. And this will be called BP_victim. And this is going to have the same mesh. I'm going to keep this simple. So I'm going to take the mesh, select my SKM Ninja, and once again, rotate it by 90 degrees. And in order to get the same exact elevation as my other character, I'm going to go into BP Ninja, select the mesh, and right-click on its location and copy that. And in my BP Victim, I'm going to right-click on its location and paste it. And this is very important. If you're syncing up animations, it's important that they have the exact same elevation so that they sync up properly. Now, BP Victim needs its own animation blueprint, and that's going to be perhaps even simpler than my Ninja's animation blueprint. So I'm going to right-click, go to Animation, select Animation Blueprint, get that skeleton from my Ninja, create that, and call this APB_victim. And the victim doesn't really need a state machine. It's just going to stand there. So I'm going to use my idle animation directly, and I'll go ahead and get a slot node as well, so that way my victim can play its getting strangled animation. So we're going to have an animation montage for the victim for being strangled. So I'm going to compile that, go back into my victim folder, and I'm not going to make any folders here. This is going to be simple. I'm just going to make a new animation montage. So I'm going to go to Animation, select Animation Montage, choosing that skeleton. I'm going to call this AM Being Strangled. And in this animation montage, I'm going to search for the being strangled animation that I have here. And this one doesn't have root motion. It's just standing there and getting strangled. So pretty simple. So just a basic animation montage. It's just going to play the getting strangled animation. If I scrub to the middle, you can see that the character starts grabbing the neck and struggling. So this is going to look pretty cool. And my ABP victim is just going to idle and play that animation. Now, in order to play this animation, my ninja needs to know who it's assassinating. In other words, I should have a variable that we can populate when the ninja is close to the victim. So I'm going to add a variable here, and this variable's type is going to be BP_victim, and it's going to be an object reference, and I'm simply going to call this victim. And our ninja needs to know when it's close to the victim. So the victim can basically have a collision box that will populate that variable on the ninja when it's close. And this allows us to only be able to assassinate the character when it's behind the victim if we place that box right there behind. So I'm going to select the capsule and add a box collision. And I'm going to move that box collision back a little bit and change its box extent, and this will basically allow us to determine when exactly our character can assassinate this victim. So I'll go ahead and move it to about where I'd like it to be. We don't want our ninja to be able to assassinate the victim if it's, say, in front of the victim. We only want this to be possible if we're behind the victim. So I'm going to make this about this size here. And I'll call this box victim box. And in order for the ninja to know who it's assassinating, our victim needs to populate that variable. So in the victim's event graph, I'm going to select the victim box and right-click in the event graph and use onComponent, begin, overlap. And we'll simply take the other actor and cast it to a BP Ninja. And if it is a BP Ninja, then we'll set that BP Ninja's victim variable. So we'll get that as BP Ninja node, search for victim, and we'll set the victim. And we'll simply set it to this particular victim. So we'll get a reference to self. So I'm going to type reference to self, get that reference to self and hook that into the victim. And that way, when the ninja overlaps with that box, its victim variable will be set. And as soon as we stop overlapping, we should reset that variable. So I'm going to select my victim box and type onComponent end overlap. And I'll go ahead and copy these nodes, not copying the reference to self, as we're simply going to set that victim to nothing. And I'll hook my other actor into that cast, and now we have the character's victim variable. And this allows the ninja to know if it's even close to a victim. And we can even check that victim variable before we even try to play a montage. So I can get that victim, and I can convert it to a validated get. And that way, if it's not valid, we'll simply do nothing. And if it is valid, then we have a valid victim to assassinate. So we'll play our assassination montage, but we'll also get the victim, and we'll call play montage, and we'll select that being strangled montage, and we'll play that right there. So let's see how this works. All we should really see is the two characters playing their animation montages. We haven't implemented any motion warping or anything, so there's nothing in place that's going to position our characters perfectly so their animations sync up. We're just going to play those montages. So what I'm going to do is drag in my BP victim here, and I'm going to put it right in front of my player start and press play. And now if I left click, nothing happens, but if I get close and left click, now I can play that animation montage. Now I see that my victim is not actually animated, which means I need to implement my animation blueprint. So I can select my victim's mesh, I can choose my ABP victim, and if I press play, I can sneak up behind the character and left click, and now I should be seeing both of those animation montages play, and they're playing in sync. The only problem is our positions are off. So that is going to be a problem. And that's where motion warping is going to come into play. Now, I did notice the victim stand back up, and that's not exactly what I want. So what I could do is have a Boolean on our victim for whether or not it's been assassinated. So here on the victim, I'm going to add a new variable and call this dead. And I'll compile and make sure dead is set to false by default. And as soon as the character is assassinated, we should set that dead Boolean to true. So I can get my victim here. As soon as we assassinate it, we can get that dead variable, set that to true, and now our victim will know if it's been assassinated yet. And in our ABP victim, we can actually have a state machine that allows us to transition to that dead animation. So I'm going to add a state machine. It's not really going to be locomotion as this character just stands there. I'm just going to call it idle. And I'm going to remove that idle animation and hook my idle state straight into the slot. And here in my idle state machine, I can drag in idle and I can drag in dead, and we'll transition from idle straight to dead if that dead Boolean is true, which means we need the dead Boolean here on the victim animation blueprint. So what I'll do is go to the event graph. We'll override the function blueprint initialize animation. We'll try get pawn owner and cast it to BP victim. And we'll promote this to a variable and call it character. So we'll have our character. And in blueprint update animation, we'll use a validated get for character. So we'll get it, convert it to a validated get. And if it's valid, then we'll access its dead variable. So we'll search for dead, we'll get that. And I'm going to promote this to a variable and call this character dead. And we'll set this every frame. And in our anim graph, for idle to dead, we'll use character dead. So if that ever becomes true, then we'll go from idle to dead, and there's no reason to go back to idle. So we'll compile and save, and now if we assassinate the character, we should get the strangling animation. We know that the positions are off, but that's okay. As soon as that character falls back down onto the floor, they should stay there because they transition into the dead state. Now my camera is still colliding with the capsule. I don't really like that, so I'm going to go into BP Victim and select the capsule and go into its collision presets and show the collision presets. And I'm going to change this to custom and ignore the camera for the capsule. And I'll do the same thing for the mesh while I'm at it. I'll go to collision presets, and change my character mesh to custom, ignore the camera, and now I shouldn't get that camera colliding with that character. Okay, perfect. And as soon as I start playing those animation montages, I notice that I have this sort of weird movement from my victim. It sort of moves a little bit, and for that reason, I'm going to go to AM being strangled, my animation montage, and look at my blend settings. Right here for blend in, I'm going to change blend time to 0 so we don't have any blending when we start playing that animation montage. And now there's no weird movement when we start that animation. All right, so we have everything set up. And if we start our animation from the correct location, then this can look pretty good. So if I'm directly behind the character and at the right distance, then when the animations play, I mean, it doesn't look too bad. I mean, it doesn't look great, but it looks like the two animations are at least in sequence. But the problem is if we're at an angle, say right here, then as soon as we start these animations, once the two animations start going together, we can clearly see that they're off. And this is where motion warping comes into play. So let's see how we can get motion warping working with this project. All right, so the first thing we have to do is hop back over to our BP Ninja. And in order to use motion warping in this class, we need a motion warping component. And we can't just click add and search for motion warping because this is actually part of a plugin that we have to enable. So let's go to edit and plugins, and we can search for motion warping. And here it is. It's simply called motion warping. We can check the checkbox, and it's warning us that this is an experimental version. So they are indeed still experimenting with this, but we can still use it. We're going to click yes, and we have to restart for this change to take effect. Okay, so after restarting, I can go ahead and click open to show all my asset editors that I had open. And back in BP Ninja, I can add a motion warping component. So I simply click add under components and search for motion warping. And there it is. And that's all we need to do here. We just need a motion warping component in order to use motion warping. And now we have to use one of our montages that has root motion. So as of the time of this video, motion warping only works for animation montages that use root motion. You can't use it in a regular animation sequence or in a state machine. It has to be in a montage. But we are playing our Assassinate montage, which does have root motion. So I'm going to open that montage. So in order to use motion warping here, I need to create a motion warping notify state. So in my notifies bar, I can right click and add notify state and select motion warping. And if I hold Control and zoom in with my middle mouse wheel, I'll see that this is a notify state. It has a duration. And I need this motion warping state to span across a section of my animation where I want motion warping to occur. So I'd like motion warping to move my character while the character is walking up towards the victim. So basically from about here to here when he goes to grab the victim around the neck. So I can expand my notify state. And a nice trick is if I hold shift and I move this, I can scrub through the animation to see the animation pose at the time I'm scrubbing at. So what I can do is have motion warping all the way up to this point right here just before grabbing the victim. And what motion warping will do is move the root component of my character during this notify state. And I can give this notify state a target to move to. In fact, we can even rotate the character to face the correct direction. Now, we have some settings here in the details panel for our motion warping state. The first is the root motion modifier. This is the setting that we choose to determine the behavior of the root motion that we impart on our character. Now, we're going to select skew warp for this, as skew warp is going to change the location of our root component as well as its rotation, whereas scale is simply going to scale the animation itself, either stretch it out or shrink it down. So we want skew warp. Now we can expand the drop-down for root motion modifier, and we have a warp target name. So we choose a name for the warp target for this motion warping notify state, and later in our character blueprint, we can specify a location associated with this warp target name. So I'm going to call this warp target name victim. And we have more settings such as warp translation. We definitely want that. That's going to result in controlling our root motion. Ignore z-axis does what it says. Whether to ignore the z component of the translation, Z motion will remain untouched. So if our animation raised our character in the air, ignore z-axis would not affect that. Warp rotation also does what it sounds. It rotates our root component based on our target, and we have a rotation type. Now, default is going to result in moving our character so that it matches the rotation of our warp target. Optionally, we could change this to facing, where it makes the character face the sync point, but as long as our warp target has the rotation that our character should match, we want default. Now, there's a time multiplier here, how fast the rotation is warped. We can leave that at 1, but you can experiment with that on your own. So now that we have a warp target called victim, we need to set that from our character blueprint, which means we need a target to set it to. Now, our victim can have a target. In fact, we can really use anything for the target, such as the transform of the character itself, but we're going to see that that's not quite what we want. Let's say we do use the character itself as the warp target. Let's see how that works. Let's go back into BP Ninja. And here, when we're doing our assassinate functionality, we can simply get the victim, which should be set here, and from the victim, we can call getActorTransform, and we can use this transform for our target. Now, in order to set our warp target, the target called victim that we associated with this notify state here, we have to use our motion warping component. So we're going to drag that out, and from motion warping, we can use add or update warp target, and we have several options here. We can use add or update warp target from location and rotation. We could also use from component, but if we choose add or update warp target from transform, then we can hook in a transform for the warp target, but we do need to specify the warp target name. We called it victim in our montage, so we're going to use victim as the warp target name, and now that victim target will use this transform that we're passing in. So let's see how this works. I can press play, and I'm going to hit tilde show collision so I can see these collision volumes. And if I go up to the box and start the montage, we'll see a couple things. For one, their capsules are colliding, so he's trying to go up to the victim, but stops just short of the capsule. So that's one problem. So taking care of that should be relatively easy. We can just disable collision on the capsule. So this is our victim here. We can get the victim, and we can get its capsule component. So get capsule component. And from the capsule component, we can call set collision enabled and set it to no collision. So if we disable collision on the victim's capsule, now we'll see, if we show collision, once we start the montage, that once we get up to the character, we won't be blocked by the collision, But there is an issue. We're going a little too far because we're matching our transform to the victim's transform. So we're a little too close. So in order to take care of that, we need a different target to get the transform of. So we'll go to the victim and we'll add a component that we can use for its transform for the target. Now, if we want a component that has a transform, but really nothing else, a scene component is perfect for this. So I'm going to add a scene component called scene. We'll change this to victim target. And this scene component can be moved back. I'm going to move it back in the X direction by roughly 54. Actually, negative 54. That'll put it right about there. So if we use the transform of this scene component instead, our character will stop just short, and hopefully that'll sync up our positions perfectly. So back in BP Ninja, instead of using the transform of the victim itself, we can get the transform of the victim target, and that is the scene component that we added. So we'll get victim target, and from get victim target, we'll use get world transform and hook that in as our warp target. So let's go ahead and press play. I'm going to show collision, and we'll go up to the box and start the montage, and we'll see how close we get. So we'll stop right about there, and that looks great. I'm going to go ahead and hide collision, and now we can see that these animations are in sync. So this looks great. Now, a couple of things to do here. For one, we still have the victim. So if I click my left mouse button, I'll see that I'm still trying to assassinate this character. The character gets back up and we play this whole game again. So that's not what we want. So as soon as we assassinate the character, we want to set that victim variable back to nothing, back to none. So I'm going to set victim right there. And I also don't want to be able to set that again. So in BP victim, we can go to our event graph, and we can only set this if we're not dead. So we'll have a branch right here. And the condition will be dead. And only if dead is false are we going to do anything for this end overlap. So we'll do that here, and we can also add that branch down here. Only if dead is false should we trigger anything for the end overlap as well. So now if I compile and press play, I'm going to go ahead and show collision so I can see that box. And if I start the montage, we'll see how this works. Going up close, strangling the victim. As soon as the victim is dead, they'll drop to the ground. And I can keep clicking the left mouse button. Nothing happens. I can end overlap and re-overlap. Still nothing happens. So truly, the victim is dead. Now, this is really nice because even if we come at the victim at the wrong angle, we'll still end up at the correct transform, and our animations will always be in sync. In fact, I can take my victim box and make it a little bit larger so that we can come from different angles and different locations. I don't want this too large because there are limitations to this. Right? We will see sliding under certain circumstances because, well, motion warping isn't going to cure all problems, right? If I start from way over here, then it's going to slide me forward because the animation can't accommodate for such a large distance to travel. Another issue is if we start from way over here on the side, you'll see that we're rotating into the correct orientation, but we get the foot sliding there. So you have to be mindful of that. And there are tricks that you can use to kind of hide that. And lots of games do this. For one, we could bring the camera in. We can zoom in so that we can't see the feet, and we can also raise the camera up a little bit. So just to show you that before we wrap up, I'm going to have a couple of variables for the camera. So under variables, let's add a new one, and I'm going to call this spring arm length. I'm going to change this to a float, and I'm going to add another one called camera height. And I can compile and give these some default values. Now, spring arm by default for us has a target arm length of 300. And that's what I'm going to set spring arm length to in the beginning is 300. And my camera height, this is going to correspond to my spring arm's socket offset, particularly the Z. If I change the socket offset, we'll raise that camera. So if I set it to 150, you'll see that the camera goes up. So I'm going to set camera height to 0 by default. And what we'll do is, as soon as we assassinate the character, we'll set the spring arm length to something shorter, like 150, maybe 200. I'll go with 200. And I'll set my camera height to something higher, something like 65. Now, I don't want to set my spring arm's target arm length and socket offset directly here, otherwise they would just snap into place. I'd rather simply interpolate smoothly, so I'm going to use event tick for this. So in event tick, I can use interpolation. So finterp2, for example, will interpolate a float value for me. And for my current value, I can take my spring arm's target arm length. So I'll get my spring arm out here, get its target arm length, and use that for my current value. And my target can be my spring arm length. Delta time can simply be plugged straight in, and my interp speed can be something relatively slow, like 2. And if I use this interpolated value, I can set the target arm length on my spring arm. So I can take spring arm, get target arm length, and use a setter and set it with that interpolated value and hook that up to event tick. So I'm going to move these a little bit out of the way here, get them down there just to clean it up a little bit. So this is going to interpolate my spring arm length, but I'd also like to interpolate my socket offset. So I'm going to use another finterp2. I can simply duplicate this one. And this one is going to use, for its current value, my spring arm's socket offset Z component. So I'm going to get the spring arm again. And this time I'm going to get socket offset, which is a vector, but I can right-click and split the struct pin to access the Z of this. That's going to be my current. My target is going to be my camera height, and delta time will be plugged straight into delta time. And interp speed can be 2. And for this, I'm going to get my spring arm and simply set its socket offset. So set socket offset. I can right-click and split the input pin and plug in the result from finterp2 for the Z and hook this up. And now I'm interpolating for that socket offset as well. So now let's see what happens, because spring arm length starts at 300. That's what the target arm length already is. Camera height starts at 0. That's what socket offset's Z already is. So nothing will happen until we start assassinating. And then these targets will change and we'll be interpolating to them. So I'll go ahead and hit play and start this. And now we see the camera zoom in and raise a bit. So now we can't see those legs. And if they're sliding or rotating in a weird way, we're hiding that from the player. So it's kind of a sleight of hand. Now, we do need to go back to the normal values of these. So for that, we can just make a custom event to reset the camera. So I'm going to right click and make a custom event called reset camera. And this can simply set these back to their normal values. So set spring arm length back to 300. That's its original value. And camera height can go back to 0. And we'll just interpolate back to that. And we can get to this using an anim notify in our assassinate animation. So as soon as we get up to the character, we're no longer warping our movement, so we can interpolate back. So I can add a new notify here, add notify, new notify, and we can call this one reset camera. And in the animation blueprint for the ninja, I can go to the event graph and get my reset camera event, and I can get my character. I can use a validated get, and if valid, I can call that reset camera. And we'll reset those values and interpolate back to normal. So let's see how this looks. And this is kind of cool because it's almost like a cinematic scene, but we can still control the camera. and then it goes back to normal and we can see the entire scene and it looks great. So doing this is a great way to hide that foot sliding if we're coming at a very severely incorrect angle. So now we don't even see that the feet are sliding unless we kind of rotate down. But, you know, there's other ways to limit the camera. And ultimately, if you don't want to use that hack, you can use separate animations based on the angle. That's going to take more work, but ultimately it'll give a better result. And also be careful because you don't want to motion warp if you're, say, in front of the character. Otherwise, you'll do this moonwalk and slide back. That's why I have my collision volume behind the character. So I'm pressing the left mouse button, so I can't do anything until I'm actually in this volume. But you do want to be careful with weird values of rotation because you can get some unexpected results if you're not careful about how you set this up. So this is looking great, and we now have Assassination in our game. And I'm noticing that my character is walking awfully fast. I'm going to take my character movement component, set its max walk speed down to about 300, so we're really sneaking. And now this looks great. And it doesn't matter what angle I come from, I'm always going to end up exactly at the right spot, and then these two animations will play in perfect sync, and it looks like it's supposed to look. Excellent. And just to make this a little more fun, we could make an assassination game, really where this is the only thing you do is just assassinate a bunch of characters. And, you know, you could add some functionality to where if you're not careful enough, maybe they can be alerted and kill you. But if you're sneaky enough, you can succeed in assassinating and eliminating all of the targets. So this looks great. All right, so I hope you enjoyed this video on motion warping, and I hope you have some ideas in your mind for how you can apply this to various areas in your game, such as walking up to a door, picking up an item, walking up to a torch and picking it up. There's really tons of possibilities when it comes to motion warping. And as you've probably seen in the Valley of the Ancients demo, we have Echo, the character who fights that big robot, and she can vault over different things in the world based on using motion warping so that she can sort of vault over different sized objects. So motion warping is something you can use in parkour, for example. So there's lots of applications to this. So I encourage you to play with it and see what you can make. All right, so if you enjoyed this video, go ahead and like, subscribe, hit the bell for notifications, and if you'd like the project files, join my Patreon. You can join any of my tiers and get the project files for this, and then you can make this on your own, but you can do this with any project that has animations with root motion enabled for the animation. Also, join my Discord if you'd like to place any tutorial requests for future tutorials. And as always, thank you so much for watching. I appreciate everyone's support. I'll see you next time.